All right, it's good to be back with you. We're recording a session here for the first part of section 5.1, and we're going to talk about the introduction to inferential statistics. We have talked a lot about descriptive statistics, which is when we're doing some calculating to figure out what we're analyzing data sets to figure things out about them. And now we're going to switch to inferential statistics, which is when we take samples and then we try to make some educated guesses or inferences about what the parameters would be. So here we're going to start looking at samples and making some educated guesses or inferences. So the goal in statistics is to figure out what's happening with the population. What are the parameters? So we're just going to start making some educated guesses or inferences based on the data that we have, and with that we might introduce some errors. So we'll have an error range, and we could even be incorrect. Those are real things that can happen when we're making inferences. Now, the analogy used here in the text, or the analogy used in the text, not necessarily here, is about fishing. So if I'm out here fishing and I've got a fish over here, I'm an excellent artist, no sweat here. What we're doing is making an educated guess, and you can think of that as like throwing a spear at this fish. Now that one looks like it could be headed towards the fish, but the fish could dodge it. The water could change its trajectory, but we're basically making a guess here. You can think of this as like a point estimate. And so from our sample, we might get X bar, we might get a proportion P, but we're going to get a value and we're going to use that as our educated guess. Now what we want is a little bit more assurance we're getting closer. We're going to have some kind of error range, and you can think of that as fishing with a net. So if this guy here casts a net, and again, pretty artistic here, try to not make it look too much like a ball, but we still have a point estimate here in the middle. We still have some kind of educated guess as to what we're starting with, but we're casting a broader net around it. And that's going to kind of bring in to play our error range. And so what that looks like here with an example, trying to choose my color here, but it's not letting me. Okay. Okay, go back to a lighter color. Here we have an example. It says a sample finds the average time spent on an iPhone is 4.5 hours. The researcher concludes that there is 90% confidence that the error in this sample is no more than 1.5 hours. And so we have here an average time spent, so that's X bar is 4.5 hours. There's a confidence level of 90% and an error of, what was it, 1.1 hours. So when we're thinking of this as like, here's our spear point estimate right here, and this is our error range, the net we're casting is within an hour or 1.1 hours. So what I do is I'll get a lower limit by taking the point estimate and subtracting the error, and this is 3.4 hours. And then I'll also get an upper limit. We don't have a three-dimensional thing here because we're really casting for a single number, and so this is 4.5 plus 1.1 for 5.6 hours. And this gives us our confidence interval, which we can write mathematically as an interval 3.4 hours to 5.6 hours. And a true mathematician might leave off the units. But that's our confidence interval. And what that means, coming up here, the interpretation, what do we mean by this? Because we have a confidence level and we have an error and we have an interval now, we can say we are 90% confident that the true mean, or the population mean, or that parameter is between 3.4 and 5.6 hours. So with statistics, we're looking to figure out how does this apply to a situation. So here we have a context, the average time spent on an iPhone, we have an error range, we have we have a confidence level and an error range. So we can be certain, 90% confident anyway, that the true mean for the population, that parameter, is somewhere between 3.4 hours and 5.6 hours. Another example, a sample finds a proportion of left-handed people is 0.13. The researcher concludes that there is 99% confidence that the error in the sample is no more than 0.015 hours. So now we're dealing with a proportion. I'm going to call that P, 0.13. Our confidence, 99%. And our error here, 0.015. I'm not sure how the hours crept in here. Definitely a typo. But going back here, giving ourselves a confidence interval, we're going to take the proportion, 0.13, subtract 0.15, and I said 0.13. It's actually 13 hundredths, or 0.13 instead of 0.013. I don't remember what I said at this point. Anyway, when I subtract the error from the proportion here, I get 0.115 for the lower, and then for the upper, I have 0.13 plus now the error, 0.015, and that gives me an upper value at 0.145. So my confidence interval here, this is a proportion, so it doesn't really have units. I'm not sure what happened there. Didn't like my 5. There's something about the 5. It's got a demon. Anyway. And then again, another interpretation. What does this mean? We are 99% confident. We want to make sure we have our confidence level in there, that the population proportion is between 0.115 and 0.145. And if I wanted to add, I could say the population proportion of left-handed people, something like that is there. And sorry about the hours error. So confidence intervals in general, we're going to have some kind of target here that we're hitting. This is the parameter. This could be mu, this could be p, something for the population. And what we're doing is taking samples, and these samples give us ranges here just based on our analysis, and some will hit and some maybe will miss here. See, these are the intervals here. And so our confidence interpreted here for like 99%, it would be that 99 out of 100 of those would capture oops, wrong button here, but 99 out of 100 of these intervals would contain the actual proportion. We're not guaranteed that we're going to get all of them, but that changes a little bit depending on how wide of a net we cast and those kinds of things, which we'll talk more about the errors and the net casting and all of that fun stuff as we continue. Up next will be hypothesis testing.